Okay, so letter your paper A, B, C, D, E, F, and label each picture as a translation, a reflection, a rotation, or a dilation. Transformation. What type of transformation is A? Edriel? A reflection, very good. And Ganesh, what was Santa reflected over? It's a reflection, and we'll get more into this today, but what was Santa reflected over? Very nice, the x-axis. Alton. B. What'd you get for B, Alton? And Karthik, how many degrees was that candy cane rotated? Yeah, good job. 180-degree rotation. Very nice. Okay, Abby, you have C. Very good. C is a translation. And we don't really know how much it's been translated. The picture isn't zoomed in enough for us to really tell, so we'll skip that part. Rishi, D. Good. D is a rotation. And Eric, if I went from here to here, how many degrees did I rotate? Yes, that would be a 90 degrees if we went in the manner that I drew that arrow. Very nice. Relina, what about E? What is E? N? Yep, reflection, very nice. And Johan, what was it reflected over? Very nice, reflected over the y-axis. And Araceli, what is F? Very nice, by process of elimination, right? F is a dilation. Okay, all right, the unit's over, that's it. Just kidding. Okay, so we obviously know an overview of this unit. So what we're going to do is today we're going to do translations and reflections. Tomorrow we'll do rotations, and we won't actually do dilations until after the break, after the winter break, okay? All right, so you're welcome to take notes, or you're welcome to just watch, whatever you feel comfortable with. We're going to study 4 different types of transformations, and those were all reflected in our warm-up today. A transformation is a change in the position, shape, or size of a geometric figure. So, why do I have a bunch of triangles on my slide? Because they all do something. So let's look at this first one. That is a reflection, right? That one, ooh, a rotation. This one, dilation. And this one, oh, where'd it go? A translation. Okay. For a lot of these words, well, for all of these words, there's a geometric term, and then there's like a slang term or like a street term. No, it's not really either of those. But there's another way to say it. So I want you to think of a translation is a slide. I want you to think of those going together. Translation, slide. A reflection is a flip. A rotation is a turn. And a dilation is a resize. So like I said, there's 2 words for each of these, and those other words kind of really describe what's going on. Okay? Okay, so I'm going to use these terms throughout the unit. Pre-image and image. And it gets kind of confusing, but the word pre means it comes first. So the pre-image is the original one. The first one we drew is the pre-image. And then the resulting figure after you complete a transformation is called the image. So there's the pre-image that becomes the image. A transformation, we use the word maps. It maps the pre-image to the image. And we draw an arrow to show that the figure has been transformed. When we transform a figure, we can't call it ABC anymore, because those are totally different points. So we call it A prime, B prime, C prime, like Optimus Prime, right? So when you transform A, it becomes A prime. And if you transform A prime, it'll become A double prime and A triple prime. You get the idea. It's kind of like tick marks, okay? So an arrow shows it's been transformed, and the prime also shows that that is the image. Okay, so let's focus in. Let's zoom in on translations. A translation or a slide is when all the points go the same distance and the same direction. All of the points together, they move together, the same distance in the same direction. When we translate things, we're going to have a rule. So x is going to become x plus or minus a. I kind of want to put plus or minus. You're going to move it left or right. And then y becomes y plus or minus b. You can do plus or minus depending on where you want it to go. This will make more sense in a minute. Okay, so my graph is really light. I need to fix that. Now, as I'm sure you could figure out yourself, what you could do is you could take each point and you could go 5 to the right and 4 up. You could use the graph to find the new points. 1, 2, 3, 4, 5. 1, 2, 3, 4. You would call the new point A prime, and then you could figure out what that coordinate is, 0, 5. Good job. So 4 units up means take the y coordinates and add 4. Good job. Sorry about that. Okay, so like I said, we can work with a picture or we can work with the coordinates. So we would take this whole column and we would add 5. And we would take this whole column and we would add 4 to get our new values. So let's see, negative 7 plus 5, negative 2, negative 3 plus 4, 1, 2 plus 5, 7, and negative 5 plus 4. So then we could just plot our points, negative 2, 1, and call it B prime, 7, negative 1, C prime, and then connect our dots. Remember, when you translate a figure, the image is going to be congruent to the pre-image because you are moving all the points in the same direction and the same distance. Same distance, same direction. Yeah, I could understand that. Okay. Whew, okay. Mr. Frog has been translated. Find the rule for his translation. So I kind of helped you out a lot. I gave you reference points. I said, okay, look at this point A, look at the back of his hind leg, and then compare it to A prime. So when you are seeing how something was translated, you need to compare the same part of the figure each time. So I helped you out by putting the A there and the A prime there. You would have trouble trying to just use the whole frog and find out what happened. You have to have a reference point. Does that make sense? All right. So, what happened to the x values? Are you able to count on your screen? Let's see. So, here's where we're moving. We're moving to the right, so it's going to be positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, x went to the right 9, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9. So it went to the right 9 and then down 9. So the rule would be x plus 9, y minus 9. Cool? What does that remind you of? Going over and down. Maybe it kind of reminds you of like a delta x and a delta y. Good. Stairs, it reminds you of stairs. Okay. Okay, let's look at this one. I'll let you think about it, and then I will call on names. Thank you, Quan. Okay, x plus 3 and y minus 4. So we know 3 to the right means we're going in the positive direction as far as x goes, and 4 down means we're going to do the negative direction as far as y goes. Very good. Okay, Victor, thank you. X minus 6y plus 8. So I didn't trick you by putting the y one first. 8 units up. Remember, up is going to affect the y, and then left is going to affect the x. And Anna, x minus 2, very good. Y minus 7. Okay, wonderful. So that's easy enough, translating the command into the rule. Okay, now let's do it the other way around. Let's translate, oh, there's 5, 6, 7. Let's translate the rule into the words. So taking a look at example 5. 5 units left, 4 units up. Perfect. 5 left, 4 up. Doesn't get much easier than this. Quinn, what you got? 3 right and 1 up. Very nice. Last but not least, two left, 1 down. Awesome. Now's your chance to ask a question if you're confused about this. Now's your chance. Okay, so now you don't have the rule. You just have the pre-image and the image. And I want to know what happened to our point. So let's do this first one together. From 9 to 12, okay, so that means what happened to X? Wow. Had to make this lesson interesting, right? It's the Black Friday shopping. Okay, so yeah, describe it in words where the translation went. Oh, no, 9 to the right and 3 up. So just be careful. Remember, the X value is going to affect the left and the right, and the Y value is going to affect the up and the down. Okay? Ariana, are you ready with number 10? Thank you, Ariana. Okay, 6 to the right, because we're going positive 6. Apparently, I don't like to go to the left very often. And 15 up. Very good. So that one took it a little bit further. It was a tiny bit harder, but not much. So let's keep going. Now we're going to move on and do reflections. We did translations, now we're going to do reflection. So a reflection, remember, it's also called a flip. You're going to go across a line. You're always going to reflect across a straight line. We call it the line of reflection, or kind of the line of symmetry later. Each point in its image are the same distance from the line of reflection. So that's how you know where the line of reflection is. It's like the midpoint. So if this is my pre-image and I went to the red image, I'd be reflecting over the y-axis. And if I go from my pre-image to the green image, I'm going over the x-axis, obviously. Okay? But you can reflect over lines that are not the x-axis or the y-axis. You can reflect over other lines as well. Reflections in the real world. Just wanted to add some pretty pictures. Let's see, we've got reflections on the water. That's in Venice, that first one. We've got a marble. We've got a war memorial. We've got a bug's eye. We've got a space mask. Cartoon, some mirrors, some rear view mirrors, more water, lakes. Very pretty. They're everywhere. Okay, so how are we going to do reflections when we're dealing with the numbers? What are we going to do to the numbers to reflect them? So this says to reflect across the x-axis. So this is going to be our line of reflection right here. And so we want each point, or line of symmetry, yep. We want each point to be the same distance away from that green line. So C is 1 above the green line. So to reflect it, I would go 1 below the green line. So there's C prime. B is 1, 2, 3, 4 above the green line. So to reflect it, I would go 1, 2, 3, 4 below the green line. And A is 1, 2, 3, 4, 5 above. 1, 2, 3, 4, 5 below. Notice I'm not moving these left, right. Since we're reflecting over the x-axis, we only have vertical movement. And so there is A prime, B prime, C prime. Okay, so what are the coordinates of A prime, B prime, C prime? So A, the coordinates are what? 5, -5. What about B prime? 1, -4. What about C prime? 4, -1. What do you notice? What happened from ABC to A prime, B prime, C prime, number-wise? So the y value has the opposite sign. What did we do to the x value? Nothing. We did nothing to the x value. Let me see if there's no. Okay. We did nothing to the x value, and we gave the opposite sign to the y value. So xy becomes x -y. That's the rule. So if you want to flip over the x-axis, you change the y. You negate or make the opposite sign of the y. What about when you want to flip over the y-axis? You would change the sign of the x. Okay? So that's not too bad. If we're flipping over x and y, not a problem, right? Reflect the figure over the y-axis. So to reflect a figure, sorry, I'm trying to make it wider. Okay, there we go. To reflect a figure, y'all are like, please just give me my worksheet so I can do this myself. 1, 2, 3, 4.5. 1, 2, 3, 4.5. There's our dead ladybug translated. Sorry, reflected. Oh my goodness, over the y-axis. So you're learning from my mistakes, hopefully, and hoping that I just move on to the next one. So here's a summary. I'm just going to go ahead and show all of the rules. There we go. So if you're going to reflect over the x-axis, you make the y's negative. If you're going to reflect over the y-axis, you make the x's negative. And we haven't talked about this one yet, but if you're going to reflect over the line y equals x, do you know what that line looks like? You can picture it right away. If you're going to reflect over the line y equals x, what happens there? The x and the y trade places, but you don't change the sign of either one of them. So if you're reflecting over the x, you change the y. If you're reflecting over the y, you change the x. And if you want to reflect over y equals x, it's like they trade places. And so xy becomes yx. So those are rules that you can memorize when you are trying to manipulate your coordinates and reflect them over certain axes. Okay, reflect the rectangle over the line y equals x. This is the real rectangle waiting for me, and it really is the correct rectangle. I promise. See if you rotate them. If you rotate it, look, it fits perfectly. Doesn't it kind of look weird? Like it's distorted? Anyways. Yes. Y, comma, x is the rule. So you take all the points of the first one, and you flip them. Once you have enough points of your figure to draw the new one, you can just draw the new one. What line has the star been reflected over? So to find the line that it's been reflected over, you would want to find, and my graph is so light on my screen, you would want to find the line that's perfectly in the middle of these two stars. I don't know if that's perfectly in the middle because my graph is so light on my screen. Once you find the line, then you have to name it. And Johan named the right one. We are touching, you ask yourself, what axis am I hitting? Am I hitting the x-axis or the y-axis? I'm hitting the y-axis, and where am I hitting it? Underneath the origin 2. So y equals -2 is the line which the star has been reflected over. Okay, try this one, Dustin. X equals 4. Let's see. Okay. 1, 2, 3, 4. It looks beautiful. Remember, this is going to hit the which axis? The x-axis, and then you just ask where is it hitting it. And it's hitting it at x equals 4. Wonderful. Good job. Okay, let's match the transformation with the correct description. So Lars, if I number them, can you match them? You can just do number 1 if you want. I'll call on someone else for number 2, and then number 3 will be process of elimination. Number 1 is C, reflection over the x-axis. Well, you look at which one changed. Oh, the y changed sign, so very good. We're going to be reflecting over the x-axis when the y changes signs. And then you said number 2 is B, reflect over the y-axis. Well, on this one, 8 stay the same. It's the x that changed, so we're reflecting over the y-axis. Very good. And then in part 3, x and y traded places. This is like y-x. So that's a reflection over y equals x. Wonderful job, Lars. Okay, next we're going to talk about symmetry really quick. You know this already, but I'm just reminding you officially. So a figure has reflectional symmetry if you can map the figure onto itself over a straight line. So that mask has reflectional symmetry. Okay, how many lines of reflectional symmetry does a regular hexagon have?
Sure.
Uh-oh, Alton's saying 12. I drew 6 lines up there. Where are the other ones, Alton? Each vertex to a side. Drew a line through each side. Oh, my bell's about to ring because we're on a different bell schedule today. And I drew a line from side to side and then from vertex to vertex. You want me to draw one from vertex to side? I don't think that'll work. Look, from vertex to side, I don't think that would be a line of symmetry. No. In between the 6 lines? So were you agreeing 6? What about a regular pentagon? How many lines of symmetry would a regular pentagon have? Wait a minute, a hexagon has 6 sides, and a pentagon has 5 sides. So are you saying that the number of lines of reflection are the same as the number of sides? 1, 2. So this one, I'm going vertex to side. So 5. Okay, what letters in the alphabet? Now this is kind of a weird font, so think of just if it was a normal font. What letters in the alphabet